Imagine a time when there was no time, no space existed. Then, in a flash, brighter than any star, the universe was born. This was the Big Bang, a moment of unimaginable energy and density. From this cosmic explosion, everything we know came to be. At first, the universe was a hot, swirling soup of particles. It was a place of unimaginable chaos, but within this chaos, the seeds of order were already being sown. The early universe expanded rapidly, cooling as it did. This cooling allowed for the formation of the first subatomic particles. These tiny bits of matter, the building blocks of everything we see around us, began to clump together. Gravity, the architect of the cosmos, was already at work drawing these particles together. This dance of matter and energy, of expansion and attraction, set the stage for the universe we know and love. As the universe continued to cool, these subatomic particles combined to form the first atoms. Hydrogen, the simplest element, was born. Helium, with its 2 protons and 2 neutrons, followed close behind. These simple elements, forged in the crucible of the Big Bang, would become the raw materials for stars, galaxies, and even life itself. The universe was still young, still finding its feet, but the stage was set for a grand cosmic performance. Gravity, the silent conductor of the cosmic orchestra, began to exert its influence on the newly formed atoms. Vast clouds of hydrogen and helium, scattered across the expanding universe, began to coalesce. These clouds, pulled together by their own gravity, became denser and hotter. Deep within their cores, a remarkable transformation was taking place. Under immense pressure and heat, hydrogen atoms began to fuse, igniting a nuclear inferno. The universe, once a dark and formless void, was now ablaze with the light of billions upon billions of stars. These stars, massive balls of incandescent gas, became the fundamental building blocks of galaxies. They clustered together, drawn by their mutual gravitational attraction, forming vast islands of light in the cosmic ocean. Within the fiery hearts of these stars, a process known as nuclear fusion was forging heavier elements. Carbon, oxygen, nitrogen, the very elements that make up our bodies, were all created in the nuclear furnaces of stars. As stars aged and died, some in spectacular supernova explosions, they scattered these elements into the void. This cosmic dust, enriched with the building blocks of life, would eventually become part of new stars, new planets, and even new life forms. The universe, once a chaotic soup of particles, had given rise to stars, galaxies, and a dazzling array of elements. But the story doesn't end there. In a quiet corner of the Milky Way galaxy, a star we call the Sun ignited. Around it, a swirling disk of gas and dust coalesced, forming planets, moons, and asteroids. On one such planet, our Earth conditions were just right for something extraordinary to happen. Life emerged, a testament to the universe's remarkable ability to self-organize and create complexity. From the simplest single-celled organisms to the awe-inspiring diversity of life we see today, every living thing on Earth is connected to the cosmos. The atoms in our bodies were forged in the hearts of stars. The water we drink came from comets that bombarded the early Earth, and the very air we breathe was once part of the interstellar medium. We are, quite literally, stardust. The universe is not something distant and separate from us, but rather something we are intimately connected to. Every breath we take, every beat of our hearts is a testament to the grand cosmic story that began with the Big Bang. We are, in a very real sense, the universe becoming aware of itself. The universe, like all things, is constantly changing, evolving. We now know that the universe is not static, but rather expanding. Galaxies are moving apart from each other like dots on an inflating balloon. This discovery, one of the most profound of the 20th century, has led to a revolution in our understanding of the cosmos. But what does the future hold for the universe? Will it continue to expand forever, growing colder and darker with time? Or will gravity eventually win the tug of war, pulling everything back together in a cataclysmic big crunch? These are just some of the questions that keep cosmologists up at night. The fate of the universe is still a mystery, but one thing is certain: the story of the cosmos is far from over. New discoveries are being made all the time, each one adding a new chapter to the epic tale of the universe. And as we continue to explore the cosmos, both with our telescopes and our imaginations, we can be sure of one thing: the universe will never cease to amaze us.